In this video, I'm going to cover a very common system design question called design Facebook newsfeed or design Twitter timeline, etc. So they are very similar questions, so let's get started. So the first step in a system design question is always to scope this broad problem to design some specific feature requests and also define some non-goals. So first of all, we need to define the feature requests we are going to design. We are going to cover in the system design. So this is about doing some back and forth question answering with the interviewer about this is mostly about asking some good questions to clarify the scope of this problem. So what will be the, let's say, what will be covered in the system design? Let's say the first most important feature request is about post publish, let's say publish post or publish newsfeed, and let's say the second one is about retrieval, is about retrieve let's say retrieve the timeline, which include the feeds of the news feeds from my friends. So let's say the non-goal. So for example, we are not going to cover the UI UX design. So we are not going to cover UI UX mobile design, and we are not going to cover the comments, shares, like something like that. And let's say if we are going to cover the text, so are we just going to cover the text or pictures and videos? Let's say we are going to, for the feed, it could be text, picture, and video. So I would say how many videos and pictures can we have for each of the feed? So let's say it could be up to let's say up to 9 pictures in each feed, and no more than 1 video in each feed. And yeah, so that's it. And for the timeline retrieval, I would ask, what would be the strategy for sorting? Is it going to are you going to cover like the sorting strategy, like machine learning algorithm, how we are going to sort the different feeds? Let's say it is going to just based on the timestamp when the feed is published. And also, let's say, are we going to cover something like a law list, disallow list? So for example, if you don't want one of your friends to see some specific post, for example, are we going to support this feature request as well at this moment? So let's say this is another very good feature request, but we are not going to we are just not going to cover this one. But it is very likely that for some feature requests, so for example, comments, share, like, and the law list, disallow list, to be covered when you have more time in the system design interview. So let's just go with the two most important features, which is about publishing the feeds and retrieval the timeline. So so after scoping this problem, we have some very good solid feature request design. That's our goal for this problem. The next step is more about doing some constraint analysis to see the scale of this problem, what we are trying to design. So it is very different from designing a high level. It's a high level prototyping. Like it is very different between like prototyping and designing a highly scalable distributed system. So the first question, let's say, how many users do we have? So let's say we have 100 million daily active users. So for each user, let's say for this kind of system, usually it is more on the read heavy side. So let's say it is like 10 retrieval queries for each daily active user per day, and also let's say one publish query, let's say one post query per day for each daily active user. So for this one, say it is 10 retrieval queries per day. So it brings up to 1 million. It is 1 billion queries per day, and so 24 hours and 3,600 seconds per day. So we are targeting about 12k QPS for retrieval. So this is 12k for the QPS. Let's say for the peak time, it is 24k QPS for the peak time. So I think this will be reasonable. And let's say for the publish query, so based on this computation, it is about 1.4k, 1.2k. Let's say it's just a 1k QPS for the post. Let's say 2k for QPS for peak time. So this gives us an idea about the traffic. So usually for a it really depends on the cost of the query, the type of the query, but usually for a normal server it can easily handle like 1k QPS. This is about the traffic stuff. So this is about traffic stuff, and the next one is like the data storage part. So now we have several different types of the data we are going to store, like the user data and the query data. Sorry, not the query data, the post data, which is the feed data. So I think for the user data, it's not that much. Usually like first name, last name, like some nickname, exact, or something like that. So for that user data, we can choose to use RDBMS to store that. But for query data, due to the nature of the large volume of the data and for the business logic, we don't require any massive select and massive join. So it is pretty natural for you to use some non-SQL to store the data. But we are going to cover that later. So for the data storage parts, let's say for 10%, 10% of the query contain 10% of the feed contain the video. Let's say 20% of the posts contain pictures, and let's say 20% contains pictures, and in average is just one picture for this 20% of the feed, and let's say 70% are just text. So let's do some simple storage analysis to see how much of the space we need. So let's say this 10% of the posts contain the video. It is let's assume it is 100 megabytes in average for each video, and for a picture, let's say 2 megabytes for each picture, and say for the text it is 1 kilobytes. So for the 100 megabytes, we have, this is so how much? So 100 million and one post request 100 million, so it says 10 million, and this is 20 million, and this is 70 million per day. So 10 million per day, each is 100 million, 100 megabytes. So it is going to be, this is 1 gigabytes, 1 gigabytes, 1 terabytes, let's say 1 PB. So it is like 1 PB. So megabytes, then it is gigabytes, and then terabytes. Yeah, so it is 1 PB, and for this one it is gigabytes, terabytes, it's 40 TB per day, and this one it is 70 GB per day. So let's say for the next 5 years, so per day this is per day storage. Let's say for the next 5 years, how much of the space do we need? Let's say 365 days per year, and 5 years is about 2000 days, so it is 2000 PB we need, and this one it is about 80 PB, and this one it is about 2000, it is 140 TB. Yes, so that's mostly about the data storage part. So I assume for this kind of system we don't assume any TT, so I think we may assume we may have some TTL, but I would say the TTL is going to be very long, because for each of the user, it is not only about the user, it's not only about the news feed. We also have like my own timeline when I see all of my posts. So we definitely need to store the posts for a very long time. And we have the traffic and data storage. The next part, let's say we have 99.99 availability, so which means for each year we only have like 7 minutes for the downtime. And let's say for the latency, so this is availability. We are designing a highly available system, and also let's say for the latency, what will be the requirement? Let's say the SLO is let's say 99% of the queries to be served within, let's say, 200 milliseconds. So having said that, we have quite something defined here, and also about the consistency. So what will be the requirement? So the consistency we are worrying about is something like, let's say I have two friends, friend A and friend B. I publish a post. Do we need to have friend A and friend B to see my post at the same time, or is it okay to have some latency, like friend A see my post like after, like 5 minutes after friend B see my post? Is that okay? So let's say that's okay, but we definitely need some eventual consistency. So eventual consistency is like so after all, friend A and friend B both are going to see my post, although may not be at the same time. Maybe there's some delay, but they are going to eventually see my post on their timeline. So having defined the constraints and the scope, the next step is about system design overview. So design overview. So for the design overview, it is mostly about the high level design, like the architecture design. So usually we will need to define the high level architecture and talk about some overall data flow, and then and also we have the components defined here, and in the next part we are going to talk about like some detailed design about different components. So let's say, suppose I'm a user, so I will send a HTTP request to the service. So first of all, it is going to hit the load balancer, of course, and then after the load balancer, it is a front-end server. So usually if the front-end server is going to send some RPC request to the backend server, and the backend server is going to update it depending on the request. It could be update the DB, retrieve data from the DB, or insert some new data into the DB. And usually if you're querying the data, there is a cache layer before that. So that's a very high level about the data flow, but we need to define the specific components we are going to have. So due to the nature of this kind of system, it's more because it's more on the read heavy side, so we need to construct the timeline for each user's for each user when it is so suppose I post something, we need to based on the post, we need to construct my friend's timeline to include my post. So that's how we define like a read heavy system. But for a write heavy system, we just don't need to update all my friends' timeline, but we just insert my post into the database, and when the user try to query their timeline, they are going to retrieve based on based on their friendship relationship, they are going to query each of the friends the posts and then construct their timeline. So that's the difference between the read heavy system or the write heavy system. But we are targeting a read heavy system, so we are going to construct the user's timeline when there is to construct the friend's timeline when there is a new feed. So having said that, we are going to define some components. First of all, I would say I will define a feed service. So the feed service, there are two APIs. The first one, it would be something like so based on the the request is the feed, let's say the feed ID, and then the response is the feed, and we are going to define the request and the response as a proto buffer, and for the response it includes the feed, which is very general. But because it has different types of the data, so for text it is going to include the original text. For pictures, it is going to include the path to the picture. For the video, it is going to include the path to the video as well. And it's worth to mention that for picture and video, it is served via CDN to speed up reduce the delay for the user to see the video or the picture. And the second API for the feed service, it would be to post so to post the feed. So the request is going to include the feed, and then the response is going to be the status, whether the feed has been successfully inserted into the DB or not. So something like that. I think, yeah, not only the status, but also we need to have the feed ID for it. So like for this one, the response would include the feed ID and the status. So for this, so we have the feed service, and we will have the we will have another one, which is a very important one. We will call it the fan out service. So the fan out service is mostly about the post, so feed post or feed publish. So for the fan out service, it is mostly about first of all, it is going to call the feed service to insert the feed into the DB, and then it is going to call the, let's say there is a graph DB about the friendship. Let's call it friendship DB or friend DB. Call the friend DB to retrieve the friend a list of the friend IDs. Let's say the list of let's say this is user ID list. It is about my friends. So let's say I am so I want to publish my post, or I want to publish my feed. So first of all, it is going to call the feed service to insert the feed into the DB, and then we get the feed ID, and then it calls the friend DB to retrieve a list of the user ID, which is about my friends. And then it is, so based on the user list ID, it is going to update each of the users timeline with the feed ID. So then it is update the each user in the user ID list, each user's timeline in the user ID list to insert the feed ID. So this is a fan out service. So you can see that suppose I have n friends, then it is going to be an ON operation, because I need to update all of my all the friends timeline to insert the new feed ID I just posted. And the other thing is about the retrieval. Let's say that it is feed retrieval service. So this is about view. So for the view, it is mostly about, so suppose I want to retrieve my timeline, so I send a HTTP request including my user ID, and based on my user ID, I'm going to call the database. So it is, the first of thing is going to, based on user ID, retrieve my timeline. So the timeline is mostly about a list of the post IDs, or a list of the feed IDs, or it is just feed ID list. So then based on the feed ID list, I'm going to call the feed service to retrieve the original feeds. And then after we get the original feeds, we are going to wrap it as a proto buffer to send it back to the front-end server, and then front-end server is going to send like in the JSON format to the user to display in their front-end, or in their browser, in their mobile app, whatever. So that's pretty much about the components I want to define. Let's go to the next step, which is about detailed design. So in this part, it is mostly about the interviewer's interest, which part the interviewer want to drive you into. So for example, it is very common for the interviewer to ask about, like, for example, the DB design, which kind of database you're going to use, like the data schema, so something like that. So let's say for the timeline, okay, so the most important things, like it would be the timeline. Let's say the dB part. So the timeline, the dB for the timeline, and the dB for each of the feed, etc. So it's very natural to in this case for us to use some non-SQL, which is like the key value pair, because the business logic is mostly about, based on the user ID, we retrieve our timeline. So it is like we just use non-SQL, which is key value pair. And also to retrieve the original feed, it's most likely based on the feed ID, I get the original feed, etc. So let's say we use a big table. So DB, we choose to use big table, and for the big table, let's say we define the first one, which is a timeline table. So for the timeline table, the row key is pretty much the user ID, and the column we have, it would be the feed. So the column family, let's say it is a feed. So the feed, so this is the first column family, so it is called feed. And for the real column, it would be like feed, like colon the feed ID, so etc. So and for this column, we are only going to store the feed ID. We are not going to store the original feed, because we don't want to waste the space there. And also, I think since we have the timeline stuff, it is okay for us to also have a column family about the user info. So for example, the first name, last name, etc., like the user profile data, to wrap it as a product buffer and store it as a different column family. I think that's perfectly fine in our case. And also another table I want to define, let's say it is the feed table. So for the feed table, the row key is pretty much the feed ID, and we have the column, which is content. So for the content, we can design it as a proto buffer. So let's say for the proto buffer, we have several different fields. Let's say the first field is the text. Yeah, so if it contains some text, we are going to definitely have some text. And also we could have, this would be like a optional string of the text, and then we are going to have a optional field. Let's say it's a repeated field of the string. You can see repeated field, it's just like a list. So it is going to store, so it is going to store the path to the pictures. So it is a pictures, and also it could have the videos, etc. So if you're not familiar with protobuffer, that's perfectly fine. Just you need to mention about what you're going to store in the column. That's perfectly fine. So for the feed ID, we have a corresponding column family for it, which is a content. And so for the column family, actually we just have one column, which is the content. And then we are going to store the text of the proto, the pictures, the videos. So for picture and videos, it's a file path within the Google file system to the original picture or the video. So another thing is yeah, so I think that's mostly about the DB part. And for the DB part, I think it's worth to mention about the data replication and sharding, etc. So for data replication, we are going to have some uh, master slave structure to make sure that we have different copies, we have enough data duplication, and also from the data serving side, if you have that different replications, it is also, let's say we deploy we have multiple duplicates around the world, let's say in 5 data centers or 3 data centers around the world, then when we retrieve the data, we are just going to retrieve the data from the nearest data center. And also there is some option which is like which can store the data in memory for the big table for faster data retrieval. So we don't need to worry too much about the data replication or the speed, etc. And because we are using big table, it is very natural for the sharding, so we don't need to worry too much about sharding. We don't need to worry too much about sharding. And after that, and I think that should be pretty much it about the DB part. So let's say which part potentially we are going to dive into for the next. So we have the request from the okay, so maybe another thing is the feed service. So for the feed service, for the first one, request to response, request including feed ID response is a corresponding feed. This one, I think we can also do some cache. We can include some cache layer for this. So for example, for some feed, it is very popular. So let's say I'm Elon Musk, and I publish something. I have a lot of the friends, and it is very common for the same feed to be retrieved multiple times. So I would say it is very helpful to set up some cache layer to cache the feed to the feed ID to the feed. And for this one, inserting the feed into the DB, I think there isn't too much to talk about here. And what else? So for feed retrieval, based on the user ID, retrieve my timeline and call the feed service to retrieve. I think that should be good for this retrieval part. Let's see the post part. So call the feed service to insert the feed into the DB, and get the feed ID, and then we will retrieve on my user ID list. And also I think for the friend, for getting the friend list side, we may also need to introduce a cache layer to cache the friend, to cache my friends. So for example, so this, I think this wouldn't be a very large it wouldn't be very large regarding the size of the data. And also, suppose I'm a frequent user, so suppose I just keep refreshing my my timeline page, and this is going to initiate multiple requests to retrieve my friend, the user ID list of my friends. So if we have the cache set up on top of that layer, this can also help us speed up the future queries as well. And also I think there is a very important question, I think. So there is a very famous question, and which is asked very common, which is celebrity problem. So the celebrity issue is that suppose I'm a very popular person. I have a lot of the friends. So let's say like Elon Musk, there are a lot of the friends or the followers. Suppose let's say I have let's say 10 million friends. Let's say I have 10 million friends. It would be very expensive to update each of my friends' timeline, because every time I have a post, it is going to update 10 million timeline, which is super expensive. So instead, what we would do for this kind of to resolve this kind of issue is usually we will so for this kind of celebrity problem, usually instead of doing like a fan out service, we just instead of the fan out service, we just insert the post into we just insert the post into like the user ID and the post ID into the user's DB, and it is so when suppose I follow like Elon Musk, and Elon Musk post a news feed. It is at the request time. I will just merge Elon Musk's feed into my timeline. It is not like when Elon Musk post the feed, and it's not like Elon Musk post a feed and then it is going to update every friend's timeline, but instead it is about so we are going to merge. So for so let me just write it down. So for people who have a lot of friends, let's say suppose it is larger than 10k. So that's how we define the popularity. So let's say a person who has 10k friends, we are not going through the fan out service. But instead we are going to so during the time people query their timeline, we are going to merge the celebrities post into the timeline. So instead of going through the fan out service. So that should be that's a very important problem which could be asked pretty often in the real interview. So other than that, I think we should be good. So that's it for this system design question. So if you have any question about the solution or about anything, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.